just it's something new. And so function composition is what it's called. Function composition. So function composition is when you're putting two functions together. So you got the function composition of f of x and g of x. So all right. The notation for that is this little circle in the middle. It looks like we're writing the word fog, but that's not an O. That's just a little circle, empty little circle there. F composed with G of X. So that's how that's read. F composed with G of X. That's how you read that. What that means is you take whatever function is listed second in the composition statement, it goes in for X in the first function. Okay? So take second function, one that's listed second, and put it in for X in the first one. Okay? And they'll change letters and they'll change the order and all that stuff, but it's always the second one into the first one. Okay? So you're kind of working right to left on that. Okay? F composed with G of X. Now, when you're dealing with that, it's functions, and every time we've talked about functions, we've talked about domain. So we want to talk about domain. So domain, what is domain? X values. It's all the X values that work, okay? So, but since we're dealing with two functions at the same time, it's the set of all X values in the domain of G of X. And I'm in brackets there, I'm going to put the second function, meaning the one that's on the right of the composition statement, such that G of X is in the domain of f of x, the first function listed. Okay, that G of x right there, that represents the y values from the second function. That's what that G of x represents. Okay. So what happens is you start out with some x values for the G of x, you get the y values that go with those. Those y values are now the x values that go into the f of x function. It sounds kind of twisty in words here, but once we start doing problems, it's not as twisty as it sounds. Okay. So when you're dealing with domain, remember we had red flags, right? What's the first red flag for finding domain? X in the denominator. So that's not anything new. The second red flag was what? Not in the exponent, but in a square root. Or even root. Square root is the most common even root, and that's the one we see the most, but it technically goes if it's a fourth root, or fifth, or a sixth root, or an eighth root, or something like that too. So x inside of that square root, we get some issues with that. All right, so those are the two red flags for domain. That hasn't changed. That's still the same. Okay, if the second function has restrictions. And when I say second function, I mean g of x. In this case, when it's the second function listed in the composition statement, if it has restrictions, then the composite function has those same restrictions. This is where it gets a little different here. So we find the domain of g of x. If it has restrictions, then that is automatically in the domain of the composite function. The next line is not always, but only if the first function, and in this case it's the f of x, has restrictions, then we must find when the second function g of x meets those restrictions. So even if you did composition in Algebra 2 very much, you probably didn't do much even if we saw that, depending on what semester it was. I know last spring we lost a lot of time because of the storms and stuff, and I think in the fall we didn't get through everything that we were supposed to out of that. So even if you didn't do it, it's good. You're gonna learn it today. Not a hard thing, but this part is a little deeper than what we did in Algebra 2. So we're taking that same concept that's covered in Algebra 2, going deeper with it anyway. Okay, so it really starts making more sense when we do some examples of this. So let's get some examples and see what all this wording stuff means. Okay. All right. So here's our first functions. F of x equals 2x squared minus 3. And then g of x is something easy like 4x. So we're starting out really easy here. Okay. So when I'm doing this and they want me to find f composed with g of x and state the domain. Okay, so that's the instructions of what I'm supposed to do. Okay, the first thing that I want to do is find the domain of each piece. So looking at f of x, are there any red flags in f of x? No. So what is the domain? All real numbers. So negative infinity to positive infinity. Then I'm going to get the domain of g of x. Are there any restrictions on g of x? No red flags. No x in a square root, no x in a denominator. So that is all real numbers. So negative infinity to positive infinity. What that tells me, if there are no restrictions on either of those, then there can't be any restrictions on the composite function. So I can tell, before I even find the composite function, I can tell you that the domain of f composed with g of x is going to be all real numbers without ever finding the composite function, because there were no restrictions on either of the two functions that we're putting together. Now let's do the actual composition. So doing the composition, we're taking f composed with g of x. So I'm going to write out the notation. F composed with g of x means take the g of x function, put it in for x in the f of x function. So we're taking this thing and putting it in there for x. That's what that means. All that means. So we have 2 parentheses, and then we got 4x, and that's squared because that x was squared, and then minus 3. And we're going to simplify that. So what happened first? Squaring the 4x. So what's that turn into? Not 8. 16x squared, yeah. And then we're going to multiply by the 2. So that's going to give us 32x squared minus 3. And there's my composite function. Nothing else I can do to simplify that. These are not like terms, so I can't put them together. Now, looking at this equation, are there any red flags in it for domain? No. So it makes sense that the domain was all real numbers, because this didn't have any red flags either. Okay? So red flags are they show up in the originals. They're going to show up in the composite. Okay, so we got to deal with them either way. All right. So let's go to one that actually has some restrictions. Okay. Example B. Here's f of x, the square root of x plus 3. Here's g of x, 2x plus 5. We're going to do the same thing. We're going to find f composed with g of x and the domain. That's what we're doing, the same operations here. So before I even start the composition, I'm going to do the domains. Okay. So I'm looking to take the domain of f of x. Mr. Isbell, reminder about your attendance. Yes, ma'am. Thank you. Everybody's here. Get to do it when everybody's here. So, is there a red flag on the f of x? Yes. How do we deal with that? How do we find the domain there? Been a minute. This is chapter 3 stuff. Got a square root, got x plus 3 inside of there. What kind of numbers can we not take the square root of? Negatives. So I'm going to take the x plus 3 and set it greater than or equal to 0. That's not how I'm going to find the domain for that. So this tells me that x has got to be greater than or equal to negative 3. That's the domain for f of x. I'm not really worried about writing it in interval notation here because that's not going to be the answer. I want to write that final answer in interval notation. That inequality version is probably better for me right there. Now I'm going to go and I'm going to do the domain for g of x. What do we know about the domain of g of x? Yeah, there's no red flag, so it's all real numbers. Now, I'm just saving myself a little writing by writing all real numbers like that. Okay. Now, here's where this gets more interesting, because the first function in our composition statement, so this is that blue line from up here. This is what we're doing. Because the first function, f of x, had restrictions, we got to find out, when does g of x meet those restrictions? When are the y values for g of x greater than or equal to negative 3? Okay, so that's what I've got to answer. I got to answer, when is g of x greater than or equal to negative 3? The easiest way to answer that is just take whatever g of x is equal to, 2x plus 5, and set it greater than or equal to -3. That's going to, and solve it. That's going to tell me when is that function greater than or equal to -3. Subtract 5, 2x greater than or equal to -8, divide by 2, x has got to be greater than or equal to -4. Okay. Now I can write the domain for f composed of g of x. The domain of your composite function will always have the restrictions from the second function, and then if there's restrictions of the first function, when does the second one function work that way? Well, the second function had no restrictions. It was all the numbers. So the only restrictions on the domain are where the second function met the restrictions of the first function. So it's only x is greater than or equal to -4. All x is such that x is greater than or equal to -4. That's the set notation. What's the interval notation for that? Not everybody wants. No. All right, so because it's greater than or equal to, so we're starting at -4 and going up to positive infinity. Is it a parenthesis or a bracket on the negative? Bracket, because it's equal to. We hadn't done that in a little bit, so jumping back on an old horse, sometimes it gets a little tricky. All right, so we found the domain without finding the composite function. That helps. Let's go ahead and find the composite function. So let's find f composed with g of x. So we're taking the g of x function, taking this guy, and we're replacing x in that function. Okay. So square root, and instead of x, I've got the 2x plus 5, and then I have the plus 3 still underneath that radical. And I'm just going to simplify it as much as I can. 2x plus 8, wouldn't it? There's my composite function. If I took this composite function and followed the red flag rules, I would set 2x plus 8 greater than or equal to 0 and solve it. I would get x is greater than or equal to -4. The thing you've got to watch out for is when your second function has restrictions. Okay, so let's look at an example where that happens and what that does to us for us. Okay, so here's our two functions: f of x, 1/4 x plus 7, and g of x is going to be 4 over x minus 1. Okay. We're going to find f composed with g and the domain. So taking each function, finding the domain. So the domain of f of x, does f of x have any restrictions? No, no red flag, so that's negative infinity to positive infinity. I don't know what happened to my parentheses there. Fix it. Now g of x, red flag? Yeah, I got x in the denominator. How do I handle that? What do I do to find the restrictions on the domain there? We did this in chapter 5 too, because that's a rational function. What we do with the denominator? Yeah, set that denominator equal to 0. If it's something that needs factoring, factor it. In this case, it doesn't. There's nothing to do except for get x by itself. So x equals 1. So that tells me that the restriction on the domain for g of x is x can't be 1. Okay? So the second function has restrictions, but the first one does not. On this one, I don't have to do that third step, okay? Because this first function in my composite statement doesn't have any restrictions. The only restriction for the composition is this one. That's it. If the second function has restrictions, it automatically is in the domain of the composition, okay, of the composite function, okay? So the composite function, so f composed with g of x domain would be all x's as long as x does not equal 1. Now, how do I write that in interval notation? We need to refresh ourselves on that.
Negative infinity to 1 union 1 to infinity.
There you go. Good job. Now let's actually go over here and find f composed with g of x. So that means we're taking the g of x function, taking this guy, putting that in for x. So we're going to have 1/4 times this fraction, 4 over x minus 1. And then we got the plus 7. What happens when you multiply those two fractions together? What can you do here and here? The 4 and the 4. Not cross multiply, but cross cancel. Cross cancel. So 4 goes into itself once and into this 4 one time. So those 4s cancel each other out. And we end up with this fraction 1 over x minus 1 plus 7. They don't really like to leave their problems like that, where it's mixed with a fraction and a non-fraction. They want it to be one big fraction. Okay, so this is where we got to do a little bit of fraction work. Okay, so I'm gonna write the 7 over 1, just so it looks like a fraction. Now, the common denominator. If I'm gonna add fractions together, I got to have a common denominator, right? So the denominator over here is x minus 1. The denominator here is 1. The easy common denominator is always just the product of the two denominators. You just multiply them together. What's 1 times x minus 1? Yeah, 1x minus 1. So this fraction already has the x minus 1. This one needs an x minus 1 because it doesn't have it. It just has a 1. So I'm going to multiply the bottom by x minus 1. But if I do that to the bottom, I got to multiply the top times that. Okay. And that's going to give me 1 over x minus 1 plus 7x minus 7 over x minus 1. 7 over there looks stupid. Let's fix it. Still doesn't look great, but that's okay. Now, when we put those together, how do you add fractions? What do you do? Once the denominator is the same, what do you do? Add the tops. 1 plus 7x minus 7 is going to be 7x minus 6, right? And there is our composite function, like they want it. A little bit next level work, getting the common denominator, adding fractions together. That's why I put that into the Khan Academies on that, because adding, subtracting fractions comes up in this. You got to be able to do that. Okay. Now, domain, everything but 1. There's our function. Look at the denominator. If I set x minus 1 equal to 0, would I get 1 being the restriction? Absolutely, out of that. So what you find on your composite function should work well with what you find for your domain. Okay. All right. Let's look at a recycling of a couple of functions. Let's say we had f of x is the square root of x plus 3, and g of x is 2x plus 5. That should look familiar. That's from example B. But this time, let's find g composed with f of x and the domain. So they turning it around, doing it the other direction. Composition the other direction in this case. Okay, so I'm going to find the domain of g of x first. What is the domain of g of x? All real numbers. So I'm just going to, that's the shortest way I know to write that. And then domain of f of x. How do I find it? It's a square root with an x inside. Inequality, greater than or equal to 0. You don't want negatives underneath that square root. So solving that gets us x has got to be greater than or equal to negative 3. Now, the g composed with f domain, this is where you put it together, okay? Since the second fraction had restrictions, that restriction will always be in the domain of the composite function. If the first one had restrictions, then we'd have to go and do that extra work. This case, g of x is first, and it doesn't have restrictions. I don't have to do the extra work. This is going to only be my only domain. Is that x has got to be greater than or equal to 3, negative 3, excuse me. So there's my set notation. What is that in interval notation? Very good. In a minute, but we're getting back at it. Good. So if the second function has restrictions, those automatically show up in the composite domain. If the first one has restrictions, it's usually not going to be exactly that number. You're going to have to do a little extra work. You got to do that extra step. So let's go ahead and find that composite function. So g composed with f means we're taking the f of x function and putting it into the g of x function. So we're taking this thing and replacing that x. Not a whole lot I can do to simplify that. Actually, there's absolutely nothing I can do to simplify that. Because this got a square root on it. Everything's locked inside of there. This 2 doesn't do anything. You're not going to redistribute it there. The plus 5 doesn't have a radical on it, so I can't put that together. That's all there is for the composite function here. So g composed with f of x is that. Look at the red flag on the composition. Same as this, right? So composition, once we find that function, should match up with that. Sometimes we kind of lose it in there and it gets hidden, but we've got to be careful of that. Let's look at another fraction one so we can get some practice with it. Example E. Let's change letters. I'm tired of F and G. So h of x is x squared minus 5x plus 7. And then let's do k of x instead of g of x. K of x. 3x over x minus 2. Okay. We're going to find h composed with k of x and the domain. This one is a challenging one as far as the algebra goes. But so, domain of h of x. Let's get that. What's the domain of h of x? Yeah, all real numbers. No restrictions on h of x. It's a quadratic, so it's all real numbers. Domain of k of x. X is everything but 2. Because you set that x minus 2 equal to 0. Get x equals 2. That's the thing x can't be. So all x's, as long as x does not equal 2. Or from, and I'm not worried about writing interval notation for that because I want to do the composite domain. So the domain of h composed with k. Do I have to do the extra step on this one? No, because the first function didn't have restrictions. Okay. I started to tap that. Screen would be nice. All right, now, so what would the domain of the composite function be? Both.
X is
Everything but 2. So it matches up to our second function stuff. So what's the interval for that? Negative infinity. Let's do a better infinity there. That didn't look like a hamburger. Yeah, parentheses all around there. Good job. So there's the domain of the composite function. Now, if the reason I'm going through finding the domain without finding the composite function first is because sometimes that's all they want you to do. I'm going to show you why being able to do that is important because we're going to go ahead and find this composite function. If you've got to find the composite function to find the domain of it, you can run into some really tough algebra. If the only thing they want is the domain, you don't necessarily have to find the function. In this case, I'm asking you to find it, but I want to show you, it's kind of like one of those lessons in, don't touch the hot stove kind of thing. You really don't learn it until you actually do it. You touch the hot stove and you find out why I told you not to touch it. So let's do that composition here and see why this is better to be able to find the domain first. So let's do that composition. So h composed with k of x. All right, so we're taking the k of x function, that big fraction, and put it in for x in the other function. So that's 3x over x minus 2 squared. Not plus, but minus 5. Times that fraction, 3x over x minus 2 plus 7. And I'm going to write 7 over 1 because everybody else has a fraction. I felt bad for 7, so I'm going to make him a fraction. I'm going to make that 5 a 5 over 1. Now I'm going to try to simplify as much as I can. Remember, I want to end up with one single fraction at the end. Right now, I have 3 of them. Technically, 1, 2, 3, 4 of them. So I want to end up putting that into one fraction. So let's work that out. So the top, so when we're squaring a fraction, what gets squared? The top, so that's going to be 9x squared. The bottom also gets squared. So that's x minus 2 squared. I'm not going to multiply that out into the trinomial because it's not going to help me. I'm just going to write the squared on it. Now the second part, what does that become? Good. And then this stays a 7 over 1. I thought you said this was hard. Well, it ain't yet. That was the easy part. Now let's get into the fun part. The fun part is the least common denominator. Okay. So remember I talked about on the last problem that had fractions in it, I said the easiest way to find the common denominator is to multiply the denominators together. Well, in this case, you got the same thing on a couple of the fractions in the denominator. And you got one that's not anything like it, okay? So if it were just, if I covered up the 9x squared over that, the big one here, what would be the common denominator between those two, the 15 and the 7? What's the common denominator between those? Be x minus 2. Now, when I look at that guy, what does it have? It's got an x minus 2 and another x minus 2. It's got two of them. So the common denominator, to match this guy, you got to have two of the x minus 2s. So this one already has two. This one only has one. So this fraction needs another x minus 2. So I'm going to multiply the bottom by x minus 2 and the top by x minus 2. Now, the third fraction, it just has a 1. It doesn't have either of those. So it's going to need x minus 2 and x minus 2. So we are on the top part, we are going to need to multiply that out so that we can put like terms together. The bottom part, you don't have to multiply out. Okay? So the bottom part, the denominator, the common denominator there is x minus 2 squared. This is going to be negative 15. I'm going to change that to negative 15 plus 30. And change that to a plus sign in the middle.
Shouldn't it be
15 times.
But we multiplied negative 5 times 3x on top.
Ah, that's 15x. You're right. 15x squared. And that's a 30x. Now, how did I do this? How did I change this to a plus sign and then make that a negative 15 and a positive 30? Why was I able to do that? What did I take with me? That negative sign right there. I took it with the 15. If I don't, I could run into some sign issues when I combine like terms. So if that's a minus sign in front of it, take that with you. Negative 15x times x is the negative 15x squared. Negative 15x times the negative 2 is the positive 30x. If it's a plus sign, you don't have to deal with that issue. If it's a minus sign, you do. Okay, so this is where this gets a little ugly. And then you got x minus 2. I'm just going to write it x minus 2 squared because that's the same thing as x minus 2 times x minus 2. The last piece, I got the fraction. I got the x minus 2 squared on the bottom. But on the top, I'm going to multiply out x minus 2 squared. If I multiply that out, that's going to be x squared minus 4x plus 4. And then I'm going to distribute 7 to that. That's 7x squared minus 28x plus 28. This one stays the 9x squared on top. So kind of ugly so far. Now we've done the really hard parts. We got the common denominator and we multiplied all that out. Now comes the easy part. Put the top together, like terms. We've got a 9x squared, a negative 15x squared, and a 7x squared. 9 and 7 would be 16. Negative 15 would be 1x squared. We got a positive 30x and a negative 28x. It'd be plus 2x. We got a 28. And then on the bottom, we have x minus 2 squared. There is my h composed with k. That was the letters I used. Yeah, it was. So if you encounter one of those and they ask you just to find the domain, I don't want to have to go through all of this and find the composite and then find the domain. I want to be able to find that domain before I have to find that composite. Because a lot of times, like on the final exam, this is where I'm drawing this from, they will just ask for the domain of the composite function. They won't ask for the composite function. They want the domain of it. And being able to do that instead of working all this out saves you a ton of time and some sweat and gray hairs out of that. That's as tough as they get, really. If you had to find a composite function, that's the hardest that it could be out of that. Now, let's do a couple of the ones where we don't have equations, but we have ordered pairs. Okay, so here's our table. So we're going to do like a 3-level table. So I'm going to have the first row is going to be my x values. The second row is going to be f of x. And the third row is going to be g of x. So -3, 11, -8. -2, 9, -3. -1, 7, 0. 0, 5, 1. 1, 3, 0. 2, 1, -3. One more ordered pair, last one. 3, -1, -8. Okay, so x values on the top. The ordered pair for the f of x is going to be that x value with the 11, that x value with the 9. The ordered pair for the g of x is going to be this x value with that y value. Okay, so they're writing it in this little double stacked table. Okay. Now, with one like this, they're asking us to find a composite function value. Okay, so we're going to do like 4 examples from this one table. Let's do f composed with g of 1. Okay. Now remember earlier I said you work from the right to the left on composition. So on this one, we're going to find g of 1 first. So g of 1 is what we're finding first. So to find g of 1, I go to 1 as the x value. And what is the y value for g of x at 1? 0. So because g of 1 is equal to 0, I'm going to be finding f of 0. G of 1 equals 0. Then 0 goes in for the g of 1. And then, so that's my new x. So I go back to the x row and I go to 0. And I'm going to f of x this time. Final answer would be 5. Okay. So this is the x value. It goes into this one first. Get the answer for that. That becomes your new x value. That goes into this one. We're working from right to left. All right, let's do another one. Let's do g composed with f of 2. So where are we going first? 2 goes into what first? F. So I go to 2 on the x. My f value is positive 1. Now that becomes my new x value that's going into g. So I go to positive 1. What is the value for g when x is 1? 0. Kind of starting to make a little bit more sense now. Let's do another one. Let's say we had, let's do the other direction with that. F composed of g of 2. So the other direction with that same starting x value. Okay. So where do we go first? 2, -3. That's the g of x. -3 and 11. Yeah. So the y value that goes with Negative 3 became my new x value. The y value in f is 11. So that's going to be 11. So completely different number than the other direction of that. That's okay. All right. It's early. It's Monday. All right. Now here's the weird one. F composed with f of 1. So this one is what most of us got. What? Do what? So where does this 1 go first?
You go on X and then go down to
3, and then
up to 3, and then to -1.
there you go. Going to the same row because it's double F there. So we're going to the same row. So 1, 3, and 3, -1. So the final answer would be -1. Out of that. Okay. If you got tables, that's what it is. Okay. I'm going to sketch a graph here. It's not going to be exactly perfect, but it's okay. I've come to terms with it. It doesn't have to be perfect. Striving for perfection is a noble thing, but it leaves a lot of stress, especially on things that really don't matter as far as how perfect they have to be. All right, so got a coordinate plane. I'm going to draw this function. Ooh, I'm going to try better. Not perfect, but at least better than that. All right, so this is f of x, the blue one there. Okay, I'm going to plot some points there. That point is going to be -2, 5. That point is going to be 0, 1. Okay. Now I'm going to draw this one. I'm going to use a ruler to do it because I can. All right, so this function is g of x. Okay. Plot some points on there. This is 0, -5. And this is 1, -2. ACT gets away with saying this. Pictures may not be drawn to scale. So mine is obviously not, but we get the idea, okay? So we have a picture here. We have a graph. And they want us to find f composed with g of 1. Okay? So where do I go first? 1 is the x value for what? G. So what's the ordered pair when x is 1? 1, -2. So -2 becomes my new x value that goes into f.
So then 5 is your answer.
So my final answer would be 5. It's the same thing as the table, but it's on a graph. Okay? So it's the exact same thing as the table, but it's on the graph. So my final answer there would be 5. Let's do another one. Let's do g composed with f of 0. So on this one, where do I go first?
You go to 0, 1.
0, 1 on the f of x function. So 1, -2. -2 would be my final answer there. Exact same thing as the table, but we got to go into the graph to find it. That's really all it is. Okay. Function composition. Fun things. Okay. Practice problems on page 404, numbers 7 through 43. Then we skip a few and go to 59 through 69. Odds on all of those. But that gets you a good bit of practice. There's a lot of different ways they ask questions on this stuff, so make sure you go through those today and tomorrow to get that stuff ironed out. Okay, because most of us don't have a ton of experience with composition. get some today.
That may be the only thing that I really forgot.
Is it? Well, that's okay. It's probably one of the later things that you did in Algebra 2, toward the end. And it's one of those things we kind of squeeze in right before the EOC.